Okay, so the last couple days we have been talking about our transformations. We've talked about reflections. We've also talked about translations. Okay, reflections and translations. Today we're going to start in talking about rotations. Okay, so rotations just like it means we're rotating around a certain point. Now, all the stuff we're going to do today is going to be either a 90 degrees, 180 degrees, or 270 degrees rotation about the origin. Okay? Where is the origin at? Okay, not 1. Where's our origin at? 0, 0. Okay? So we're going to rotate everything about the origin. Now, one thing that we want to always look at is that we have our rules for rotations. Okay? They're shown here. If we're going 90 degrees clockwise, that's going to be the exact same as if we were going 270 degrees counterclockwise. It's going to get us the same part. We'll look at the y in a second. Same way, if we're going 270 degrees clockwise, that's the same as going 90 degrees counterclockwise. 180 degrees, if you notice, going either way is going to be the same. Why is that? Because 180 degrees is the what point? Is the halfway point. Okay? So, if we're looking at this, if we were ignoring this for a second, if we were going 90 degrees counterclockwise, that means we're going 90 degrees over here. Okay? 1/4 of a turn. Okay? If that's counterclockwise. If we were going 270 degrees clockwise, we would be going basically 3/4 of a turn, which would get us to the same place. Okay?
Are you really recording this to put it on?
Yes. Okay? So, if we are going 180 degrees counterclockwise, that's going to be the same as 180 degrees clockwise. So with 180, whether we're going clockwise or counterclockwise, it's going to be the same thing. And most times, they're just going to say we're rotating 180 degrees because it doesn't matter whether it's clockwise or counterclockwise in that situation. Okay? The same way, if we're going 90 degrees clockwise, that's the same as going 270 degrees counterclockwise. So if you noticed on our, as we said, on our rules for rotations, 90 here for clockwise is the same as 270 counterclockwise. You get to y negative x. Y negative x here. 270 degrees, you get negative y x for clockwise. For counterclockwise, 90 degrees, negative y x. Okay? It's going to be the same. Now, we're going to look at what exactly that means here. So, if we are looking at our number 2, okay, it says we're doing a rotation 90 degrees clockwise about the origin. Now, as we're looking at this, one of the first things we want to do is write down what each coordinate point is. Okay, so what is our coordinate point for D? What is it? -5, +3. What is our coordinate for E? negative 3, positive 4. And for F, negative 2, positive 2. Okay, so those are our original coordinates that are given to us with this triangle. Now we need to figure out what our new coordinates are going to be when we rotate that triangle 90 degrees clockwise. Okay, so if we think back to our notes, 90 degrees clockwise tells us that our new points are going to be y, negative x. Okay, y, negative x. And what that means is that our first number is whatever our original y value was. So what was our original y value here? 3. Our original y value was 3. Okay? And then the negative, or the opposite of what our x was. What was our x originally? Negative 5. So the opposite of that would be positive 5. So our new coordinate for point D is 3, 5. Okay, so let's go ahead and graph that. We have 3, 5, and there's our new point D. Okay, let's do our second point here. What was our y value of E? 4. And what is the opposite of our x value? Positive 3 now. So we have 4, 3. There's our next point. That was point E. Lastly, negative 2, 2. When we switch that around, our y is 2, and our opposite of x is 2.
So that's basically all it is.
So with our certain formula here. So if you notice, we've rotated it 90 degrees. Essentially, if we took this, kind of keep an eye on what we have. If we rotate our paper, okay, here's our original. We rotate that 90 degrees. Our new one looks exactly like it did before we had it rotated. We have just rotated our paper basically underneath it. Okay, so you're rotating that point. You're rotating this 90 degrees. Okay, 1/4 turn. Okay, let's look at number 3 here. Okay, number 3 says we have a rotation that's 180 degrees about the origin. Okay, so the same process. What do we want to start by doing? Writing down our coordinates. So we have J, K, and L. J is at what point? 0, 0. What is K at? 4, 3. And what is L? 5, 1. Okay. Now, for this one, since we are rotating 180 degrees, what are we doing to get our new coordinate points? We are the negatives of each one. So negative x and negative y. So with J, it's just going to be 0, 0, correct? Because we're not going to have negative 0. It's just going to stay 0. What about K? Negative 4, negative 3. And L? Negative 5, negative 1. Okay, so we can go graph these points. We have 0, 0. That's still our point J. Okay, we have K, -4, -3. And we have point L, -5, -1. And go ahead and connect those. And we have our 180 degrees rotation.
So if it doesn't give you a specific one, like clockwise or counterclockwise, you just gotta do whichever one.
Well, the only ones that it will not give you a certain direction is the 180, because whether it's clockwise or counterclockwise, it's exactly the same. Yeah. Right. Any questions with those? Okay.